So let's have a look at the first question, which was multiple choice. It wanted us to find the range, and we were given the function f of x is equal to x squared plus 6, and it was between -1 and 6, the domain. So let's make sure that we are reading that properly. So if you have a quick sketch of the graph, okay, it looks something like that, and it would be like that if you were looking at the full graph. Okay, but we are not looking at the full graph. We are looking only between -1 and 6. So if you put -1 into that, so when x is equal to -1, you get y is equal to -1 squared plus 6 is 7. So basically we are looking at a smaller part of the graph, and when x is equal to 6, y is equal to 6 squared plus 6, which is 42. So let's have a look at that on our graph. -1 and 7. -1 would be about there, 7 is there. Now, are we including it? No, because they were round brackets in our domain, so that is an open circle there. And then 6 right up to, it goes up to 42, again open circle, so that is 6 and 42, that was -1 and 7. So this is the part of the graph. This green bit here is what I'm interested in. Of course, that didn't affect the range because the range dropped below that. My y values actually start at 6 here. So what is the range of my graph here? So the range was from 6, because we were including that value of 6, up to infinity. So it was basically the turning point there, which made it part B. Question 2 is a pretty interesting question. Seems easy on the surface, but not really. So this one says, which of the following functions is not a one-to-one function? Now, remember, there are two tests. To test whether something is a function, we use our vertical line test. And then if it's one-to-one, we use a horizontal line test. Now, if it's not a function, then it can't be one-to-one. So what you need to work out, first of all, by looking at all those graphs, and I'd probably put them into my calculator, making sure that you keep the domain that is specified in mind. But the only one there that is not well, it is a function, but it's not one-to-one, is D. Let's have a look at D. We're looking at y equal to 3 on x squared. That was a truncus, okay? That's a truncus, and it's up here somewhere. All right, now you can see that it is a one-to-one, so wherever I drop that vertical line, okay, it is a function. But is it a one-to-one function? Well, let's have a look if we do our horizontal line. Draw a horizontal line there, because remember there was no restriction there on that domain. So I'm crossing my graph twice. So it is not 1-to-1. So it was a function, but it's not 1-to-1. So therefore the answer to that question was D. Looking at question 3, the function with rule f of x equal to the square root of 49 minus x squared, the maximal domain. So it's basically saying the domain is restricted here purely because of the nature of the graph. Hopefully you can recognise that as a semicircle. So we've got this graph that looks like this, and it goes from there to there, -7 up to 7. Now, what do we know? Are we including those endpoints? Because what we're looking for is the domain. Well, the domain is going from -7 to 7, and we are including them. So -7 up to 7 with square brackets. That's what x is an element of. Can we find the answer there? Yep, the answer is B. Question 4 just wants us to go from set notation into interval notation. So going into interval notation for the first one, we are going from -1 to 2, and we're not including, so it would be round brackets. Part B there, we're going from 4 to infinity, and we are including 4, so it is a square bracket up to infinity. Part C, okay, we are between -2 and 5, including both those endpoints. So -2 to 5, with both of them having square brackets. And D, we are looking at all the positive real numbers in union with 0. So we are including 0, not usually part of positive real numbers, but because we're including 0, square bracket with the 0 up to infinity. Okay, question 5, a quadratic function has the rule f of x equals x squared minus ax plus b. We know that f of 3 is equal to 6. Now, if we write that as a coordinate, it's telling us that when x is 3, y is 6. You might like to look at it that way more than in function notation. And the other bit there we know is that f of -1 is equal to 6. Again, as a coordinate, that is -1 and 6. Now, it says to show that a is 2 and b is 3. So we can't use those values of a and b. We have to work towards them. So let's set up some simultaneous equations here. So I'm going to use the first point, which was 3, 6, and substitute it in, and I get 6 is equal to 3 squared minus 3a plus b. 3 squared is 9 minus 3a plus b. Bring it across. Minus 3 is equal to minus 3a plus b. That's my first equation. My second equation, I'm going to use the other point, which is -1 and 6. And let's do the same thing again. So 6 is equal to -1 squared. Be careful with the signs here. So -1 squared. Now, minus times a minus is a plus a, so plus 1a plus b. So 6 is equal to -1 squared is 1 plus a plus b. Bring it across. 5 is equal to a plus b. That is my second equation. All right, now where do I go with that? Well, we've got simultaneous equations. So what I'm going to do is say equation 2, take away equation 1, because what I want to do is eliminate one of the letters. And you can see there, if I say 2 take away 1, my b's are going to eliminate. So I get b take away b, and that goes. I've got a take away -3a. So take away a negative is plus, so I get 4a. And then when I look at the 5, take away -3, so 5 plus 3 is 8. A is equal to 2. And of course the last bit there is to get the b value. So substitute a equal to 2 into one of those equations, and I'm going to substitute it into equation 1. Maybe I'll do it to 2. I think 2 would be easier, and I'm going to get 5 is equal to a, which is 2, plus b, take the 2 across, and b is equal to 3. So I've just shown that a is equal to 2 and b is equal to 3. Question 6 wants us to sketch some graphs showing the coordinates of all critical points. Now, critical points are the points that are particular to that type of graph. So if it was a parabola, we'd be showing turning point x and y intercepts. This first one is a hyperbola, so we need to find the asymptotes to start off with. So what does the equation look like? Y equal to 1 on x plus 3 minus 5. So my asymptotes are x equal to -3, y equal to -5. Now remember, asymptotes are equations. You should always write them like that. So x equal to -3 would be over here somewhere. Your graphs are going to be better than mine, obviously, but I just want to show you what they should look like. You can put them into your calculator and have a look as well. Y equal to -5. It's along there somewhere. Okay, now we need to find some information about this graph. So let's keep going. And so we get x-intercept. We're going to let y equal to 0. Letting y equal to 0, 0 equals 1 on x plus 3. Take away 5, bring the 5 over. Alright, becomes plus 5, swap them around. And x is equal to 1/5 minus 3. Now 3 is 15 on 5, which gives us minus 14 on 5. Alright, the x-intercept we've got, so that looks like minus 14 on 5 and 0. The y-intercept, we're going to let x equal to 0. And what do you get? You get y is equal to 1/3, take away 5. Again, 5 is 15 on 3. So we get minus 14 on 3. Coordinate there is 0 minus 14 on 3. Alright, so when we plot them, minus 14 on 5 is what? 2 and 4/5. So minus 2 and 4/5, which is around about there. And minus 14 on 3 is 4 and 2/3, which is around about there. Remember, they're both minus. So my graph is going to go towards my asymptote. Now again, yours will look much nicer than mine. And let's label those coordinates. 0 minus 14 on 3. This one here is minus 14 on 5 and 0. Of course, I need the other part. And remember, this is a positive hyperbola. So it's going to be down in this bottom quadrant here. What I would probably do is just take another point. We know it's going to reflect in there, but let's have a look. When x, now I need a value bigger than my asymptote, which was x equal to minus 3. So I'm going to look at something, or I should say smaller. So I'd probably use minus 6 because it's just nice if I'm not using a calculator. Y is equal to 1 on minus 6 plus 3, take away 5. So it's minus 1/3, take away 5, which is minus 5 and 1/3. Or as a coordinate, that is minus 6 and minus 16 on 3. Okay, minus 16 on 3, minus 5 on 1/3. So we know it's over here somewhere. So there's my point, and again, I'm trying to draw it so that it's moving very close to my asymptote but not crossing. So that point there was minus 6 and minus 16 on 3. So the last bit here wants us to state the domain and the range. So the domain for this graph, what's x? X is an element of, well, it's all real numbers because we're looking at all along the x-axis. And the only value it can't take is 3. So x is an element of real numbers, excluding minus 3. And the range, if you look at it that way, for the range, again, it's all real numbers, and the only value it can't take is -5. So y is an element of real numbers, excluding -5. So part B, what sort of graph are we looking at here? Well, again, it's something that you do need to be able to recognise, and you should be recognising it as a circle. It is a circle that has a centre at 2, 2 and a radius of 3. So therefore we are starting with a centre at 2, 2. So 2, 2 is there. Now this is going to be difficult for me to draw, but hopefully you'll just get the idea of it. So if we go across 3 places from there, we're going to end up at 5. 1, 2, 3, 4, 5. And there's one end of my circle, so that's 5, 2. If we go up 3 places from there, we're going to go up to 2, 5, which would be up here. So x is staying as 2, but my y is changing. If I go back 3 places from here, so 1, 2, 3, I go back to here. Oh, my graph isn't done very well, but you get the idea. Minus 1, 2, and if I go down 3 places from here, so my x value stays the same, but my y value doesn't, so it is to -1. So that looks pretty good to me. Now the next part of that question wanted me to find the domain and range. So what is the domain for my circle here? Well, you can see that it goes from my x value, which was -1 on the left hand side, and that should be a square bracket because I'm including it, and it goes right over to the right hand side, which was 5. Again, I'm including. My range in this case, what are my y values? Okay, so my smallest y value here is -1. Again, I am including it, and it goes right up to 5. So my domain and range are the same, but that's not always going to be the case. Looking at part C, we have a square root function here, and you can see this minus is changing the direction of my square root function. So what do I know so far? Well, I know that it starts at, well, my y value is 2. What's my x value? How do I work it out? Well, remember, let the thing inside the square root sign equal 0. So 3 minus 6x equal to 0, minus 6x equals -3, x is equal to 3 on 6, which is 1/2. So therefore, this is 1/2. So that's where I'm starting from, 1/2 and 2. Now, I am reflecting that. I'm reflecting it in the y-axis. Let's have a look at the y-intercept here, because it is going to cut the y-axis. So my y-intercept, I'm going to let x equal to 0, and so I get y is equal to 2 plus, okay, the square root of 3. So what does that look like for us? Well, 1, 2, 1, 2, 3, there's my y. Okay, there's my x. So my starting point, which is 1/2, 0, so 1/2 is there, sorry, 1/2, 2 is that point there, when x is 1/2, y is 2. And then my y-intercept is 0, 2 plus root 3. Okay, root 3 is just smaller than the square root of 4, so we're just under 4 there, but we're bigger than 3, so it's going to go up like that. Okay, and again it's reflected in the y-axis because of that minus. So that is the point 0 and 2 plus root 3. And you can continue to extend your graph there. Domain for this one. Okay, let's have a look at the domain. And you can see here that my x values only go up as far as 1/2. So you can write that whatever way you want to. I think a lot of you like interval notation. So we're going from -infinity up to 1/2. We are including that x value. And the range for this one, again, let's have a close look at it. Our y values start from 2 and go up to infinity. So y is an element of, okay, we are including 2 and going up to infinity, round bracket for infinity. And that is part C. So our last graph here is a truncus. Okay, You might need to look back and see what a truncus looks like, but basically you are in the same, you're either in the top or you're in the bottom. Now we know that we're in the bottom because of this minus here, so it's telling us to use the bottom two quadrants. So let's find some of the critical points here. Truncus does have asymptotes, so the asymptotes for this would be x equal to 2 and y equal to 1. All right, so next thing that we would probably need to do is think about x and y intercepts. Now, because my axes aren't asymptotes, I will have x and y intercepts. So let's do the y-intercept first, where we let x equal 0. Okay, we are thinking of trend here, aren't we? Trend, we always think about trend, and we know that we're going to be in there somewhere. All right, so x equal to 0, so we get minus 2 on 4 plus 1. Minus 2 on 4 is minus a half. Minus a half plus 1 is positive a half. So what's that coordinate? It is 0 and a half. For the x-intercept, what do? You let y equal to 0. Letting y equal to 0, we're getting 0 equal to minus 2 on x minus 2 all squared plus 1. Bring the 1 across, minus 1 equals minus 2 on x minus 2 all squared. Now the minuses cancel each other out. Okay, so let's now swap the bottom with the top of the other one, and we get x minus 2 squared is equal to 2 on 1. 2 on 1 is 2, and then we're going to take the square root of that, and it's going to be plus or minus the square root of 2. X is equal to plus or minus root 2. Bring the 2 over, plus 2. So my coordinates there would be root 2 plus 2 and 0, and minus root 2 plus 2 and 0. So let's fill in our asymptotes to start off with. X equal to 2 is all the way along here. Don't forget to label it. X equal to 2. Y equal to 1 is all the way along there. Again, don't forget to label your asymptotes. Now, all the other information we know. We know the y-intercept is at 0, a half, which is there. We know that one of the x-intercepts is at minus root 2 plus 2. So we know it's on this side of 2. So minus root 2 is 1 point something. So we're going to be over here somewhere. And then 2 plus root 2, again we're going to be over there somewhere, and so let's just draw in our graph. Again, I'm trying to make it look like I'm not going to touch my asymptotes. Again, you're using a pencil for this, so it'll look much better than mine. Okay, and your graph should look something like that. Don't forget to label what you've gone through. So that is 0 and a half. This one here is minus root 2 plus 2 and 0. And this one over this side is 2 plus root 2 and 0. The last thing that we want to do here is find the domain and range. Okay, the domain for this one. Well, you can see we can have any x value here except for x equal to 2. So x is an element of real numbers, excluding what value? Excluding 2. And the range for this one, okay, y is an element. Again, the only one we can't have is the asymptote, which is, or no, it's more than the asymptote. We can only go as far as the asymptote. So the asymptote was 1. So therefore our range goes from negative infinity all the way up to 1, but not including 1. So there's a round bracket there. All right, so the last one here, we're given f of x is equal to 4x plus 3, and we're asked to find f of 2a plus f of 1. So you do need to do them separately and bring them together at the end. And so for f of 2a, okay, wherever you have got an x, you're going to put 2a. So 4 times 2a plus 3 is 8a plus 3. And f of 1 is equal to 4 times 1 plus 3, which is 7. So bringing them together, you get overall for f of 2a plus f of 1, you get 8a plus 3 plus 7, which is 8a plus 10. Part B, you're looking for f of a plus 2 minus f of a minus 2. Alright, so let me do it like this. Same thing, wherever I've got x, I'm going to put a plus 2. So it's going to be 4 times a plus 2 plus 3. Take away. Now I'm looking at this side of things. So I'm going to put a big square bracket, and this time I'm going to put a minus 2. So 4 times a minus 2 plus 3. I'm going to tidy that up a little bit. Alright, so I get, expanding out my brackets, for a plus 8 plus 3 on that side, minus, I'm still going to keep my square bracket, and I'm going to go 4 times a is 4a minus 8 plus 3. You can see I've got a bit of tidying up to do. Now just be careful. So 4a plus 11 minus gives you minus 4a. Now minus 8 plus 3 is minus 5, but you are timesing by that minus, so that becomes plus 5, and then tidying it up completely. 4a, take away 4a, gone. So I've got 11 plus 5 is 16. And lucky last, part C, you were looking for x when what? F of x is equal to 27. So what do we get? We get 27 is equal to f of x, which is 4x plus 3. I want to get x, bring the 3 across, so you get 24 is equal to 4x. Divide by 4 and you get 6. So overall, they are the answers to that worksheet.